each and every answer, and I increased all grades. If I didn't have any notes, then it was difficult for me to increase too much. I only saw the typos, right?
Thank you.
Thank you. So it's always good to turn in your notes, because you may make a typo. So one student from the other class, for example, wrote a domain as negative infinity to infinity, and instead of putting parentheses, she put 0. Of course, she was not going to put 0. She tried to put parentheses, but didn't realize. And of course, the system gave her 0. But everything was correct. She just typed in 0 instead of the parenthesis.
Yeah, because I'm looking at my test, and one of my answers is supposed to be the bracket, which I thought I put, and I didn't. I guess I just put the line.
Yes. So I saw that, and I increased, as I said, all grades. Because I'm not interested in that. I'm interested in what you showed. But always turn in neat notes so I can give as much credit as possible. This was not going to happen if we were face to face.
So like one of mine, they put, I put my answer as x equals 0, but they wanted it to be c parentheses.
I saw that, yes.
Okay,
yes.
so that.
No, they didn't want C of t. No, they didn't want C of t. We never wrote horizontal asymptotes at C of t. We always wrote the horizontal asymptote at y equals 0, not C of t.
So
but I saw that, and I gave you credit for it. Yes.
Okay, so that's what you mean. Okay.
But remember, we never ever wrote that, because we're not talking about this function. This is a totally different function that is the horizontal asymptote, not that. I know we also call this one y, so it's confusing. But this is a second function, not that function. Does it make sense? Okay? Good. Next question. Is there anything else, or we go back to chapter 4? Anything else? Or chapter 4? Anyone? Okay, so then you can always stop me anytime. I'll go back to any question you may have. So we are continuing now with 4.4. We haven't finished, and that is logarithmic equations. We only looked at 2. So my notes are still here. No, we looked at more than 2. No, logs only 2, yeah. No, we didn't look at logs at all. Okay, any more equations that are exponential that we want to look at? Anything else with exponential, or we move on to log? Okay, so I'm going to pick a log equation next then. Log equations. On page 515.
Is this continuing 4.4 by the way?
Correct.
Okay.
So on page 515, let's start with a simple example like 52 on 515. So natural log x equals 3. So this is our first log equation that we want to solve, and we don't know any of this, but we do know that the most important concept in this chapter will help us solve the log equation, change it into an exponential. I don't see any base here. What is the base for natural log?
10.
Careful. LOG has base 10.
E.
Yes, but ln has base e. Always remember, I know you've probably not seen this before, and you haven't gotten the chance to look at anything yet. So here they are. Base 10 and LOG are on the same key, and base E and natural log on the same key. So every time you let's say, forget what is the base for natural log, look at e. In case you forget what the base for log is, look at 10. Okay, so therefore the conversion will be e counterclockwise, e raised to this number equals x. E raised to the third equals x. And that's our answer. However, note, logarithmic functions are not defined on all real numbers. I will put the correct answer will be in general. So we have two options here. When we solve log equations, we have two options. We either state domain or you check prospect solutions. So here what I would write as domain, I would write that x must be greater than 0. And e to the third is almost e to the third, 3 to the third power is definitely a positive number. So I would say yes. For me, it's easier to state domain. It's also practicing domain, which is extremely important for a log function. It's much easier than checking solutions. You can say, I don't want to state domain, but you will still have problems on the next test with stating domain, so why not practice that? And you can say, no, when I solve equations, I don't want to use this method, but I promise to check the solutions back in the original problem, which is fine. But you have to choose one or the other. You don't have to be consistent. On one equation, you can use this, and on the other, this. It doesn't matter. But you have to keep in mind that log is not a friendly function. It's not defined everywhere. So we have to worry about its domain. Okay. So now let's choose any problem you'd like from 49 through 92. And these are all on 515. I'll choose the second one and then you choose the next. I would like to jump to 68. In 68, they say log base 6 of x plus 5 and plus log base 6 of x equals 2. You know me, I'm going to state the domain for each log. I will not touch the equation before I state domain. What is the condition that I have to write for this log to exist? And what is the condition that I have to write for this log to exist? Anyone?
X is greater than -5?
Yes, I have to write that x plus 5 is greater than 0, and I have to write that x is greater than 0. Very good. Indeed, thank you. So this is greater than -5, and this is greater than 0. I will have to figure out the common domain. This is one function, this is another function, I add them up. I have to find the common domain. So on the real line, this is the 0 to infinity. And also on the real line, this is -5 to infinity. I have to choose the interval that makes both functions exist at the same time, where I see purple and red. Purple and red are both from 0 to infinity. So the common domain, 0 to infinity. Only now I'm asking myself, how do I continue? I know how to continue. I have to condense this. I have a formula for condensing, or a property for condensing, the sum of two logs in the same base. that is log base 6 of, how do I condense this?
Products.
Very good. X plus 5 multiplied by x equals 2. Great job. I don't know how to solve this, but I know it's equivalent to 6 raised to the second power. 6 raised to the second power equals this, but now I will distribute. X squared plus 5x. Okay, now this became from the log equation, it turned into a quadratic equation. So this is x squared plus 5x minus 36 equals 0. I hope that it doesn't take long to figure out how to factor, and this is it. Of course, I have to check against the common domain. So how do I factor these two? I mean, this trinomial.
X plus 9 and x minus 4.
Very good. So then we have two solutions. And you should say, not so fast. Because the condition must be that whatever we find has to be greater than 0. If it isn't, it has to be discarded. So this will go away, and this will be yes. So the second solution gets a yes because it's the only one. Please choose anything you'd like to see. Anything. From 49 through 92. Okay, I will pick, let's say 84. Same page. Log x plus 7 minus log 3 equals log 7x plus 1. Okay. I will not condense, I will not touch it before I state restrictions. What is the restriction for this to exist, and what is the restriction for that? This is just a number. I can't state any restrictions on that. So for the first one, I have to write that x plus 7 has to be greater than 0, which means x greater than negative 7. For this one, the same thing, 7x plus 1 greater than 0, or 7x greater than negative 1, or x greater than negative 1 over 7. Again, I have to decide what is the common domain. So the first one is negative 7 to infinity. And the other one is negative 1 over 7 to infinity. So what would be the common domain? The common domain is where I see both colors. I see pink and blue. That must be negative 1/7 to infinity. If the equation has solutions, they have to be here. If they are to the left-hand side of negative 1 over 7, the equation has no solutions. Okay, so now I start condensing. The right-hand side is fine.
So, I have a quick question.
Please.
So if we didn't have colors, for example, it would be where they overlap, correct?
Excellent, yes.
Okay.
That's why it's easier for me, instead of saying overlapping or common domain, I say where you see both colors, yes.
Right, okay. Thank you.
You don't have to have colors. Thank you. The right-hand side is log 7x plus 1. Can anyone condense this side for us? So what I recommend between now and Monday, work on chapter 4 as much as you can, and then let's solve some problems together from my math lab that you may have difficulties with. But make as much progress as you can, please. I would like to review for test 3 with problems from my math lab. Okay, can anyone condense this for us?
It's the ratio.
Yes, log of x plus 7 divided by 3. In the next step, I'm going to go back for a moment to an equation that we solved last time. Forget about this for just one moment. Bear with me. What did we say when we looked at 2 to the x equals 2 to the third power? Here's what we said. Two numbers are equal and they have the same base. What has to happen to their exponents? What did we say?
They have to be equal.
They have to be equal. Very good. So this was, however, an exponential equation. We are in the same situation over here. So, two logs are equal in the same base. What is the base here? I don't see the base again.
It's 10.
Very good. So two logs are equal. They have the same base. What has to happen to these numbers? In other words, I'm asking, log of 9 can equal log of 10? Log of 15 can equal log of 3? No. So what has to happen then?
They have to be equal.
Thank you. Exactly like here. So then the left-hand side, the number that log is applied to has to equal the number that log is applied to the other side. And you can say, wait a minute. How come that I didn't have this here? Because I didn't have a log on this side. So here, when I got to this stage, I said, oh, I know. 6 squared equals this. But here, it's even easier. I don't have to do that. I don't have to convert it into an exponential equation. I can only say, two numbers are equal. They have the same log in the same base. What has to happen to these two? They have to be equal to each other. Otherwise, if this side is 5 and this side is 10, they're not equal. So log 5 does not equal log 10. Log 5 equals log 5. That's why this quantity has to equal this quantity. Okay, good. So let's continue. What I recommend here, multiply everything by 3. So then I have x plus 7 equals, because when I multiply it here, of course, it goes away. 7 times 3, 21x, and plus 1 times 3, which is 3. Now this is a linear equation. You know my habit to keep the variable on the left. You do whatever you want. You don't have to follow my steps. So negative 21 plus x is negative 20x, and 3 minus 7 is negative 4. And then x is negative 4 over negative 20, or 4 over 20, or 1/5. Of course, I ask myself, wait a minute, I know log. Log is not a nice function. Is 1/5 here? Yes, it is. 1/5 is right somewhere here. So it's in the interval of the common domain. It's in the common domain. And this is the way we solve log equations. It's not enough. We only had 2. So let's choose more. We had 3, actually, sorry. So let's choose more. Okay, I'll choose. 80. Same page. 80 we have log 2x minus 1 equals log x plus 3 plus log 3. Okay. if you agree with my method, meaning to stay domain, then you will say this function will not exist if 2x minus 1 is not positive. This function will not exist if x plus 3 is not positive. This one is just a number. There is nothing to do there. So I add 1 and divide by 2. And then I subtract 3. Again, I'm looking at -3 to infinity, which is this. And I'm looking at 1/2 to infinity, which is this. And Kayla said that I should say overlap, so I'm using the word of overlap. So where do they overlap? That is the common domain. Thank you, Kayla. What is the common domain where the solutions should be, if there are any solutions? Anyone? 1/2 to infinity. The left-hand side is left-hand side. I'll leave it as is. Can anyone tell us how to condense the right-hand side? How do we?
Product.
Yes, it is the product. So I have log of x plus 3 multiplied by 3. Very good. Well, I'm back to the same situation from before. I don't need to change this into an exponential equation. I have two numbers are equal. They have logs. The logs are in the same base. There is nothing in front. So then these two must equal each other. So then 2x minus 1 must equal 3x plus 9. Like before, I'm going to do this. Negative 3x plus 2x. And then add 1 to 9. And I get that x equals negative 10. And what is our conclusion? Our conclusion is anyone? Anyone? Yes?
Well, it can't be negative 10, right?
Very good. Exactly, that's our conclusion. Very good. Would you like to choose anything else?
I got a question.
Please.
Is it possible to have a common log and a natural log in the same equation?
Not in your class, but it's a perfect question. So if I'm told, for example, I have log of 2x minus 1, and let's say here I have natural log 3, correct?
Right.
Perfect question. I have to change one into the other. It doesn't matter which one. So if I want to keep log here, remember the change of base formula for natural log 3 is log 3 over log e. So this changes into this by the change of base. So now it's still complicated because I really have to find this number, multiply both sides, or just keep it here. I have log 2x minus 1 equals, I can rewrite it. And remember, this number that is in front of a log, although it has a log itself, is the power of this. No, you're not going to have a problem like this. So then the left-hand side is log 2x minus 1, and the right-hand side will be log 3 raised to this ugly number, log e raised to negative 1. So now I set these two equal to each other. So then 2x minus 1 equals 3 raised to log e to negative 1. I change it from 1 over into power negative 1. So I add 1 and divide by 2, and so on and so forth. Do not worry, you're not going to have a situation in which on one side you will have a base and on the other side you will have a different base. But that's how we address it, with a change of base. Very good question.
Can we do number 65?
Yes,
Or
yes,
66?
yes.